Hello, everyone. My name is David Lara. I am one of your fellow classmates here in CIS 231. This is our final lab assignment, and I just kind of want to go over the document, give my explanation as to what I'm interpreting as the assignment would be, and just kind of deep dive and show you guys my code and my output and all that fancy stuff. So, this is the prompt. Write a procedure named getFrequencies that constructs a character frequency table. Input to the procedure should be a pointer to a string and a pointer to an array of 256 double words, initialized to all zeros. Each array position is indexed by its corresponding ASCII code. When the procedure returns, each entry in the array contains a count of how many times the corresponding character occurred in the string. So we're given an example down here for the data. Um, Basically, here's our string. So it'd be A, E, B, D, C, F, B, B, C with our 0 as our null terminator. We have our frequency table right here. This is our function. D word means it's double word, 256 capacity, so 0 to 255 possibilities. The image at the end shows a picture of the string and entries 41 hexadecimal through 4B in the frequency table. Position 41 contains the value 2 because the letter A, ASCII code 41H, occurred twice in the string. Similar counts are shown for other characters. Frequency tables are useful in data compression and other applications involving character processing. So this is a demonstration of what the table looks like when it's displayed graphically, of course. So this is pretty good at generating the idea of what we're looking for and what we're trying to show with our code. So basically, we're asked to submit a copy of our code and so forth. But basically, after reading this and my own interpretation of what's being asked of me to complete in this assignment boils down to something as simple as this. So the goal of this lab is to create a character frequency table in MASM assembly language using the MASM assembler and of course the Irvine 32 library that we've been using all semester long. So that is my interpretation of it. So in order to defend that, I would like to show my code. So my code is over here. So we're going to start off at the very tippy top with our included Irvine library. So this needs to be declared in every one of our assignments so that we can have access to the Irvine 32 library of functions and commands and instructions. So very useful, very important. Cannot forget to have that there. When we scroll down to the data section, I've created my test string by calling a target. And basically, this is the string that we're going to analyze. We'll be counting how many times each character shows up in said string with the value in ASCII code. So this is what we're looking for. This is what we're going to use as a reference. We've also created a function for frequency table with 256 double words. Each spot in this table represents an ASCII character from 0 to 255 and starts at 0. So I was sure to have that displayed here on the right. Our next message, or first message actually, would be the character frequency table, which is going to be used as the title of our table. The second message will be our ASCII code, which is given the ASCII code for the reference that we have here. And then we're going to go ahead and show our count. So that's going to be the count, how many times the letter is counted in the number representation. So let's go ahead and scroll down to the code. Now in the code section, I call a procedure named getFrequencies, and this function goes through each character in the string and increases the count for the matching ASCII code in the table. So for example, if the character is A, which is ASCII to 65 hexadecimal, we increase the value at frequency table 65, and so forth. So it's basically used as our scalar. So Um, this is what we have down here. So we're moving the EDX into the offset for the message to display the title firstly. We're going to call the write string to be able to show our title. We're going to display the frequency table. But basically what I'm skipping here is just where I'm setting the address of the string and the address of the frequency table right up here with the address command, with the instruction. So we're setting them in ESI and EDI so that we have the incrementation happening in EAX, EBX, and ECX. They all play a crucial role, so we need these in different memory locations. So we're going to go ahead and call the get frequencies function procedure up here. Call that. And then we're going to move on to our other function, which is going to be the instruction to display the frequency table at only non-zero values. So we're going to move 256 into ECX, and that's going to create a loop 256 times for each ASCII value. Then we're going to XOR EBX into EBX. So EBX will hold the current index of 0 to 255, and that'll be our range, our scale. We're going to go down here to our display loop, and this is where we start working with the loop. So after building the table, the program loops through the whole table and prints only the characters that occurred at least once. So for each one, we print the ASCII code and the number of times it appeared in the string. So this is what we have down here. This is going to be our display loop. So we're going to move frequency table EBX times 4 into EAX. So this will get the count from the frequency table. We're going to compare 0 to EAX. We're going to jump to the next character if the count is 0. And we're going to skip this character. So next, we'll display the ASCII code. So we're going to move message 2 into EDX. We're going to offset it and we call the write string. And then that's going to give us our ASCII code text right up here, our string. We're going to have that appear. Next, we're going to move on. We're going to move EBX into EAX, and we're going to call the write deck. So next, we display our count. So basically what it's going to do is it's going to move our values into a suitable position where it'll output next to the string that we're outputting our messages. So next, we're going to do the same for the count, which will follow subsequence for the messages. So this one's going to be the final message we display with the count of how many times it appears in the ASCII code. So all of this frequency is the same. So we're going to move frequency table EBX times 4 into EAX. And these are basically the values that we declared up here. So we have our index being tied to our function and procedure down here. And then we have our frequency table also doing the same thing. So next, when we jump from down here, if the count is 0 and we skip this character, we're going to jump over here. So basically what this line is calling is the function displayed here, which will increment EBX and loop the display loop function. So this should exit the program. And we're going to jump right into a second portion of the program, which will go ahead and be the main endpoint. And this is where our get frequencies procedure is staged. So we have our address of the string, address of the frequency table, also in ESI and EDI. And I wrote that down there just so that there wouldn't be any confusions and I wouldn't have to scroll up and down to remember where I was. We move on to the next character in string function down here, which will be moving ESI into a low, which will load the next character. And we're going to compare that to 0 to check for the null terminator. So we're going to jump if done. We're going to jump done. And then we're going to 0 extend the character to EBX from a low. So at this point, we're going to go ahead and increment the double word. So we're going to increment the corresponding frequency count and also move over to incrementing to the next character. We're going to jump to the next character in string, and then we're done. We're going to return get frequency as endpoint, and then we're going to end the program. So this all boils down to creating a frequency, creating a rotational loop where we can continue to check given certain strings to display their ASCII code values and counters and stuff. So If the string were different, we'd get different results, and I'll kind of demonstrate that in a little bit. But let me go ahead and run the program first. I did make some changes, so I'll go ahead and build it, and then I'll debug. Okay, so we're gonna go ahead and get our output on here, which will give us ASCII code 65 counted 2. So we're going to get into the output here. So you can see that A appeared 2 times, which is why the count is at 2. We're going to see that B appeared 3 times, which is why the count is at 3, and so forth. So that means our frequency table is working and we're counting characters. So that's a wonderful sight to see. Basically, this program is useful for things like text compression, and just encoding algorithms. So that's pretty much it in terms of what I created, what I was given, what my thought process was when making this, and my interpretation of the lab assignment. So there's a lot of confusion as to what the lab assignment was asking for. So I went with my gut, and this is what I was able to come up with using similar programs found online, using similar programs found in the textbook, and just basically doing my best to research and try to understand what was going on over here. But yeah, I hope I did a great job in explaining it, and I hope there's no confusion as to what we were asked for, what I was able to deliver. Um, but before we go, I want to go ahead and test this with a different string. So we're gonna go ahead and let's add 2 A's and a B, and we'll run it. See, the counters went up. So, I mean, this proves without a shadow of a doubt that the frequency table is up and running. Um, so yeah, in terms of that, that's what we're being asked to do. So just kind of bear that in mind. In terms of conciseness, I'm sure this code could have looked a lot better, a lot easier on the eyes than it does now, but I hope I did my best. I hope that my effort to streamline everything and kind of leave sidebar messages and comments on the side kind of help to explain why I utilize this and what the steps mean, and they're easier to follow for another um, person in terms of conciseness. But thank you so much for your time, and have a great rest of your day, and thank you.